Hi guys, another video. This time no power electronics, although it has to do with the power supply. Well, many moons ago I made a video about the design I had at that time, a third-party dual-channel power supply for YOGOGAWA active probes that I received from a friend. I received 2 of them. You see here the box of it. This is how it looks. And on the top, the power supply I made. Of course, the solder has nothing to do with that, yeah? So, the thing is that all the new probes from newer scopes, etc., get the power directly from when you connect the BNC or the probe to the scope. There is like a ring with pins around it, additional to the BNC connector, and this is where you get the power and the I/O communication, if there is one, etc. The older ones, like the YOKOGAWA I received, let me sit down and show you. Like this one, it's the YOKOGAWA 700-939. It's a FET probe, goes up to 900 megahertz. These older ones, like this, let's take it out. Okay, of course, everything else has to come out too. Stay inside. Good. These older ones like that do not have anything here to receive the power. So they have an additional lead to the probe lead here. They have an additional lead for the power, and that's a LEMO connector. And that's not a cheap one, yeah? And this is how you get the power. The thing is that to power those, this one, you need a power supply from YOKOGAWA. And these power supplies are really expensive. They go up to 1,000 euros almost, yeah? So no, this is not an option for me, because for a FET power supply for only 950 megahertz, I'm not paying 1,000 euros additional only for a power supply, a used one, and at this age, yeah? No. Even more that I will probably not use it at all, because the frequencies I work with are in the GPS frequency range. This is 1575.5 megahertz or more. So I checked the specs of the power supply, of the original power supply, of the YOKOGAWA power supply. I think there are 2 versions, one with 2 outputs and one with 4. The 4 one is the expensive one, yeah? But even the 2 ones, I'm not interested in that, yeah? Just for a linear power supply, yeah, with 2 outputs and a few, overvoltage protections and a few other things. Anyway, this is why I made this, can we say beauty? Or let's say nice power supply, yeah? It has 2 outputs for 2 probes. Each of the probe uses plus minus 12 volts, and the capability of this power supply, they can deliver to each probe plus minus 12 volt at plus minus a half an amp, with beautiful signaling of the voltages. Anyway, kidding. I'm using the casing of the power of the I'm using the casing as a heatsink, of course, too. I think I showed that before from one other design I made, but you will see it in a jiff in a minute when I open it. And on the back we have an IEC socket. I don't know how this, what's the name of this one? It's called IEC something. I don't know. Anyway, I use this because it takes less space and it still has a grounding pin. The whole design, let's go a little bit outside again, more zoom out here. The whole design consists of the power supply, of the casing slash heatsink, front PCB, back PCB, and inside we have the main PCB. So let's open it. By the way, why I'm showing that again, I made a video many moons ago, as I said, with that, but interestingly enough, and I was really surprised, because at that time when I uploaded the video, nobody was really interested. I got, I don't know, till now, 200 views or something. Yeah, there's absolute no interest. But okay, yeah, it is how it is. I thought perhaps it is the way of making videos at that time, and to be honest, it was very sloppy, the videos I made. Yeah. Anyway, I'm trying to make much better videos now. Do my best at least. Anyway, a couple of my subscribers wrote me an email and told me and asked me if I can show a little bit more details of the power supply, of this power supply that I made, because they are interested to build it. So why not? Everything is here. So let me open it and show you how it looks. So I unscrewed the top of the power supply as a beginning to just show you how it looks with the casing inside. So let's take it apart. And immediately you see this. Look. These are the linear regulators I'm using because I want to have this thing as quiet as possible. I will show you the whole PCB much better in a jiffy. But for now I wanted to show you the 4 linear regulators, plus minus 12 volt for the 2 channels. And they have small heat sinks on them. But these heat sinks, in reality, communicate with a big heat sink that it is the case with seal pads, these things. And this is a seal pad sandwich. Yummy. That takes, you see, even the footprints of the small heat sinks, how they are nicely and snugly connected to the seal pad and through the seal pad to the big heat sink that is the case itself. So I don't have to use larger heat sinks for that. Okay, let's continue the teardown. And I'll show you the schematic too, but it's nothing really exciting. Let's start with the back. The only thing that I don't like at this, from this casing is that they are using self-tapping screws. That wasn't necessary, to be honest. This is a very nice aluminum casing that could use metric screws, M3 or something, but it is how it is. Yeah, if I put my hands there, then it is not focusing anymore. Well, that's the back of the PCB. Grounding strip that is used to ground the casing, and connection, mains connection to the main PCB. Now that we have removed that, let's take the main PCB out. I already disconnected it from the main connectors, front connectors. So this is how it looks, guys. Additional to the regulators and tantal capacitors for filtering and regulation, everything else that you see is current protection with PTCs for plus minus 12 volt for 2 channels and overvoltage protection for the outputs. Here, I'm not protecting this side, the power supply itself. I couldn't care less about the power supply itself if something happens. I'm protecting the other side that goes to the, of course, to the probes. This is the expensive part. Yeah, then we have here rectification and some nice, what did that took? Semicon, Rubicon, I don't know, a brand, and not from China, yeah? These are from Mauser. Very nice capacitors. Come on, where is it? Here it is. 2200 microfarads, 25 volts for plus and minus. A nice block, plus minus 12 volt transformer, and that's it. Yeah, fuse. And additionally, here we have the necessary cutouts for greepage and to have the correct distances from the mains to the mains. Additionally, I put a plastic cover, even if the distance to the casing is enough. This doesn't hurt, yeah? And this is how it looks in the back. Yeah, as I said in my video at that time, all the schematics, all the design files, Gerbers, etc. are available. Just send me a request on the comment and I will tell you how to contact me. Or the easiest way, contact me at the comments. Yeah? This is how it looks in the front. And here you have the LEMO connectors. These are really expensive, guys, yeah? But they love it. Everywhere they use LEMO connectors just to make it even more expensive. So this one, front, the back. Of course I could have, I'm shamed now because I didn't clean it here. Anyway, doesn't hurt at all. And the main PCB, that's the power supply itself. And again, the seal pads. So let me show you the schematic. So here we have the schematic. Guys, it's really nothing special, yeah? But anyway, let's start rectification. The block transformer, this thing, rectification, 2 bridges, 2 capacitors, this caboozle here. Yeah, at the input I have the fuse and the connector. So after that, we go to the 1-channel regulation. This is what you see. I'm using 7812. It's not exactly the 15 what I had here. I don't know why I didn't change that. Anyway, and an additional diode here to elevate the output voltage to I think it's a Schottky diode to 0.4 volt something. That's a little bit more than 12 volt here. That's it. On both sides, plus and minus. And the filtering, input and output filtering. This happens for the 2nd channel too. And then the connection to the LEMO. The output via the LEMO connectors to the probes itself. This is very important here. First of all, to PTC fuses on each of the channels in each of the voltages, and an overvoltage protection. 12 volt bidirectional TVSs, and nothing else as the few LEDs. That's it, nothing more. Anyway, everyone that was interested in the details, in the schematics, in the design files, send me a request in the comments and I will send you the design files. Yeah, well, that was it. I don't have much more to say here, yeah? I want to say thank you very much to all my users. Again, users, I will never stop saying that. Sorry guys, again. Thank you to all my subscribers. Thank you for watching. If you like my content, if you like the videos I'm doing, please give me a thumbs up. Subscribe to my channel. Most of my viewers are non-subscribers, 75%. Guys, subscribing to my channel is free, costs nothing, just helps me to grow my channel and to give me the ability to show you more electronic things and interesting stuff. Press the notification button to get informed when I have new videos. And that's it. That was a short video this time, because it was just a revival, or how do you call it? Look, now I cannot put it inside. Ah, did it. This is how nice it works. Again, thank you for watching. Stay safe. Have a nice summer. See you next time. Cheers, guys. Bye.